Review. What we're going to cover today is three specific points. The first is what do we expect to see in a proposal, and we'll go section by section with that. Second, what is the purpose of the HERC proposal? So just to add into that here, the purpose of the proposal, this is a competitive challenge. So there are more teams that want to compete than we have space for. So with that, the proposal is your chance to let us know why your team would be a good fit. So what we're looking for in the proposal, you can see here on the scoring, it is weighted heavily towards the facilities and equipment that you have. So that's the level of support that your institution is giving you. That can be both in material support, which would be like in your budget and your project plan, or facility support. So having the facilities to perform the tests that you need to do, to build your rover, to do the research and all of that is very important. Zach will touch on that in a bit. What is less important is the design phase and any of the technical points at this point. So we're looking to see who is a good fit for this based on the proposal itself. So what is not important or expected at this stage, we'll cover that a bit in each section. Go next slide here. So key points for 2026, some of these are different than previous years. So we do have 10 obstacles this year, that is not different. And we have 3 tasks. The tasks are going to be shared by both the remote control and the human powered divisions. So it'll be the same tasks. All of the divisions will use the same course with the exception of obstacles 1 and 5, which will be a scaled down version for the remote control. So if you were around last year, you know that the transverse incline, we had a scaled down version for the RC vehicles. We didn't feel like that was necessary. I think most of the RC vehicles would have been fine going over the full size. So we are going to have them go over the full size transverse incline this year. What we have scaled down instead of that is going to be the ice geyser slalom. So it was trivially easy last year due to the size and spacing of the cones. This year there will be a scaled down version that will require a bit more of a steering challenge. All obstacles do have a bypass. I know maybe a lot of questions on this one, and that's fine moving throughout the challenge year, but just to kind of head this off now, university RC teams need to have autonomous sample collection and testing. So what that means is we don't expect anybody to have an autonomous vehicle that can come out and drive itself around, or that can recognize where it's at or what it needs to do when it gets to a certain place. What we mean by autonomous here is that the full task of collecting the sample and testing the soil, the water, or the atmospheric areas that you're going to be testing, all of that needs to be done with a single button press. So that can be on a controller, on a laptop, on a phone, on a, I don't know, if you want to send it a Snapchat message and have it go off, whatever you want to do with that. So it needs to be a single command that starts that whole process. So there is a note in the handbook that the collected sample doesn't have to be the tested sample. It can be, and I anticipate that most teams are going to do that. They're going to collect a sample and then head off and be testing it while they're moving, but it doesn't have to be. So if you want to collect a sample and also test the sample material, if that's the soil or the water, both of those have the sample collection as well as testing, you can test outside of the sample that you're collecting. That is optional though. Time limit for human powered is still 8 minutes. The time limit for RC has been moved to 12 minutes. So this is a safety concern. If you were around last year, you know that we increased the time on day 2. This is to prevent our teams from running behind the RC vehicles. The vehicles themselves, we know, can get through the course in 8 minutes. That's not an issue for most teams. The issue that we have is that the teams had to run behind it, and we want to avoid running on the course. So time limit for RC is 12 minutes this year. And just as a note, I know my drawings are really great in the handbook, so I don't have CAD software if you couldn't tell. But basically tasks 1 and 2 are these 3-foot diameter, 4-foot deep pans that are going to be buried flush with the ground. One will have soil in it, one will have water in it. The RC rovers are allowed to drive through that. they're allowed to, park on it and collect the sample from underneath. That's fine. Human power would be a little more difficult. So they'll be pulling up next to it. The drawing for task 3, what was going for here is it's a 2.5 by 2.5 by 2.5 foot cube. If you imagine the same one we used to measure the volume constraint for the RC rovers, it'll be something like that, and then on top of it will be some sort of balloon or mylar atmospheric collection chamber. It will hold some atmosphere that will be modulating a bit. So that's where you're going to be testing. So RC will need to drive underneath it and then test upward. Human power will have a tool of some sort that comes in from the side or the front and then goes upward to do the sampling, or testing rather. You're not taking a sample of the atmosphere. So any questions on that? We can kind of shuffle off until after the proposal phase. I just wanted to get this information out there for everyone as we move forward and you start to think about your designs. And with that, we'll go to the design section. So technical design, what are we looking for at this phase? It is not super important at the proposal phase that you have a robust technical design. What we want to see is that your team is maybe on the right track or has the ability to sit and brainstorm how they're going to accomplish these tasks and obstacles. So what is a general idea? We're looking for a napkin sketch level. Has everyone sat around and, brainstormed, drawn some things out, and tried to anticipate how their design is going to meet our challenge? At this stage, we don't expect simulation, finite element analysis, animation, 3D renders. We don't really want to see any of that. That tells us that the time was spent sort of in the wrong direction. So you're not going to get points off for that. But instead of spending time really focused on a design at this point, you should be focused on what's going to score you the most points, because that's what's most important at the proposal phase. So look at the facility section, look at the project plan, and really focus on those. I won't say above design, but in tandem, and then if you have extra time, make sure those sections are really well thought out and explained. So we're looking for, can you brainstorm? Can you showcase the ideas that you have brainstormed? And a rough plan for the tasks as well as the obstacles. So the second to last bullet here I put in bold. This is something we're going to bring up throughout the entire challenge year. So as we get into design review and operational readiness review as well, what we have maybe not explained well in the past, something that we're looking for, is are the relevant design goals identified? So why are you doing all of the things that you're doing? Apologies if you can hear my cat yelling in the background. So a lot of the reports start out with this idea of, you told us what to do, so here's a rover. What we want to see is you breaking down how we've asked for it. So we haven't asked for a rover. There's nowhere in the handbook that tells you what to build. We've given you obstacles and we've given you tasks. So start with those design goals and break those out into what sort of obstacles they are, what sort of tasks they are, and what sort of design goals are identified by those obstacles and tasks. And start as basic building blocks as you can, the basic ideas of what this challenge is asking for, and then build up from there with how you're going to accomplish that. And that's important at this level as well as in the future, because it helps us to see that you understand the challenge and what we're asking for, and can break complex ideas down into their basic parts to pull out the goals that we're looking for. And then, of course, challenges and plans to overcome them. Plans to overcome them are vital at this section. So in your proposal, every team has challenges. If you can identify those challenges and let us know that it's a challenge, and here is how you're going to get through it. For a lot of teams, it's funding, it's budget, it's how are we going to get money. So if that is a challenge for your team, identify it. Don't just have a really low forecast budget and not talk about it, because then we see that and we're like, do they know this is probably not enough? So talk about it and let us know how you plan on overcoming it. Are you going to do fundraising? Are you, looking at your school or local businesses for funding? And this could be a challenge in manufacturing as well. If you don't have the material or the space or the tools to do something, where are you going to do it? What is your plan for that? That is all I have. I'll pass it off to Zach to continue. Thank you.
Okay, so keeping in theme of what are we expecting at the proposals, like Chris has already mentioned, one of the key factors or key points to discuss is your facility equipment, tools, and materials, which is generalized here as the facilities and equipment's requirements. So what do we expect to see in the proposal? Well, we would like for you to describe and sort of explain or detail what facilities and tools and like equipment, what materials, what kind of things is your team going to need, and then break it down into which of those do you already have, which facilities do you have access to, what tools are included in those, what materials does your team maybe already have in stock, and also identify the facilities, the tools, the materials, any of the equipment that you do not have, including things like the example I listed here. You may have a desire, like say especially if you're in the RC division, you may have a desire to 3D print a fair number of the piece parts, right, in the construction of the rover, but maybe your team doesn't have access to a 3D printer or one of adequate size to make the parts you're looking for, or the types of materials you're looking to print with, right? You might have a resin 3D printer, but not one that can do extrusion printing, and for different materials, there's only really one way to go about printing them. So you might have some shortfalls, right, where you can't access a certain material, or you can't access a certain method of production or manufacture, and we want to know what are those? What do you have and what don't you have? And the reason for that is we want to see that your team is aware of the kinds of shortfalls and the obstacles they're going to have to overcome. What challenges will you have in fabricating your rover? And your team is not going to be eliminated, or your proposal isn't going to be not accepted because you don't necessarily have access to all the facilities or all the tools, right? It's not like the team that has the most of these is the one that we're going to accept. What we're interested in seeing is that your team is aware of what they need and what they have and don't have, so that you can make a plan accordingly, right? One of the keys at the proposal phase is to prove to us, the review team, that your team is capable of completing the entirety of our program, right? It's not actually all that beneficial to you or to us to have you get accepted because you can do a really great rover design, but then only to find out that you don't actually have the access to the equipment to make any of the rover, to manufacture the rover. You have no plan for how to get it fabricated outside of that, and then you end up either dropping out or not being able to finish your rover because you didn't have that sort of contingencies planned for. It's actually a much better case for you to not have access to a facility, but have a workaround plan and to talk about that in your proposal, so we know that you're at least aware of this and you're going to take all of the reasonable steps to make sure that you do finish the program. That's one of our primary goals, is to see that every team we accept comes to Huntsville and participates in the competition. So identify your facilities and then, of course, what facilities or tools, etc., you don't have access to. We also want to know, with regards to the facilities and equipment, what special requirements are there in order to be able to utilize those. Example of this might be there might only be certain hours of operation for the machine shop at your school, right? And including that information is important because it shows that it shows us that you understand you can't just go in there any time of day. Or conversely, maybe you can go in any time of day, but you have some sort of requirement where you have to have completed a training class, and then they badge you get a badge that lets you into the machine shop. So you can only you have access, whereas other students might not. and understanding that you have to finish those training classes before you will be granted access shows that you understand some of the other steps you're going to have to take in order to access your facilities and be able to actually complete or build your rover. Finally, there is no, we don't have a set list of the team has to have, these kinds of materials, they have to have this kind of machine shop or access to these kind of tools and so on. But you need to demonstrate to us that what you have and what you're going to get is going to be adequate or sufficient to build the rover that you're planning and that you're designing, right? And that changes based on, the style of the design. And that's why we do need a sort of a rudimentary design, not a super fleshed out one, but with, basic level materials, sizes, shapes, etc., so that, we can sort of compare, is this team even going to be able to build a rover like the one they've described, given the access to facilities and equipment and so on. Next slide, please. Sorry, take a second to update here. Okay, next up we're going to talk about safety requirements. Now this wasn't as big a portion of the score, but that doesn't make it unimportant by any means. So what do we expect at the proposal phase with regard to safety? So what we don't need is a completed hazard analysis. Just like we don't need a complete design, we don't need a completely fleshed out hazard analysis and a failure modes analysis for a rover that isn't even designed or built yet. That doesn't make sense. What we're actually looking for at this point is, again, this understanding of what is to come so that you can get through all the different review milestones and not, drop the ball when it comes to all these different deliverables. So with that in mind, we want a safety plan, and what that basically boils down to is we want you to show us or explain to us how are you going to identify safety, safety concerns, risks, hazards to personnel, risks to your equipment, failure modes of your rover and your task tools. And then once you've got those identified, how will you go about mitigating those? How will you protect the personnel that are participating in your program when they're fabricating the rover, when they're testing the rover? How will you identify, how will you mitigate the failure modes that you've identified in the design that you've come up with? And sort of what processes do you have, or what design constraints have you sort of imposed on yourself that will ensure a successful competition rover when the time comes? And finally, what sort of training plans do you have that goes into that? Some of the, especially with regards to personnel, hazards and risks to the people on your team, is going to be mitigated through knowledge and understanding of the tools you're using, how the rover works, etc. And you need to plan for that in advance, right? If someone needs to have a training in order to use, a tool during fabrication, they need to have that training before the time comes when they need to use the tool, right? So we want a sort of a plan of what training classes, what briefings, like shop talk type stuff is your team going to need to do? Who has to attend them? Who has to present them? What kind of material should be discussed? And roughly when do these need to be presented, or do the team members need to participate in these trainings? That's relevant, again, to show that you understand not only what it takes to be safe, but when it has to happen in order for it to be relevant at the phase of the program you're in. And finally, we expect teams to identify their student safety officer, which is, of course, a person on the team. This isn't like your faculty members. This is a student. And identify what are their roles, what are their responsibilities with regards to this program, right? So given that they are the safety officer, and they will likely have other duties besides just that, but given that they are the safety officer, what do you expect them to be doing as part, as their role of safety officer, and how does that tie into the program at large? Next slide, please. All right, next we're going to talk about the timeline. This isn't something that really needs to be in your proposal. This is just something that you need to be aware of with regards to your proposal. And the entire timeline is available in the HERC handbook, but notably, there's one date on this list that is super important to you right now, and that is the proposal, the very first one, the proposals submitted deadline. The proposals are due and cannot be submitted any later than 8 a.m. Central Time on September the 15th. Any proposals submitted after that will not be accepted. So I encourage you to submit your proposals early. And the submission, the instructions for how to submit are found, I think, both on the website and in the handbook. But that brings us to a bigger point, which is read the handbook. A lot of the questions you will have throughout the course of the year are actually addressed in the handbook. But obviously, if you're still confused after doing that, just feel free to ask us, or in this presentation or any future ones. But yeah, the only date really on here that matters is that September 15th. We'll discuss the remaining dates in future webinars if and when your team is selected. Next slide. Okay, next up is the project plan. So what do we expect with regards to the project plan? Well, first off, the project plan is basically a two-part thing. It's your logistics sort of summary. It is the timeline, your schedule, and your budget and funding, right? The finances part of the project. And this is a very important part of the proposal for the sole reason of teams. The two biggest reasons teams do not finish or succeed in HERC are because they fell behind and could never catch up as far as like the delays in manufacturing design and fabrication and so on and testing, or they ran out of money or didn't ever have enough funding to finish the program in the first place. So with that in mind, we want a pretty well fleshed out schedule, a timeline of events for your program. And that starts at the time of proposal submittal and should run all the way through the competition. And we want to know not just when are the dates that we put in on the timeline, but what are the dates in your team's specific timeline? When are you going to test? When do you have to build? Not even just build the rover, air quotes, but like when do you build subsystems and piece parts? Is there any quality assurance or testing, verification of the function of these parts before they're integrated into the rover as a whole? Again, like I mentioned earlier, what training needs to be done and when as a precursor to doing some of the fabrication or design or whatever. The more fleshed out your timeline is at the early stages, the better, because then and you can show to us that you are aware of what it's going to take to get through all the different phases on time and be able to get to the competition with a completed rover that's been tested and ready to use. One final thing there with regards to the timeline or the schedule is understand that rarely does everything follow the schedule perfectly. So you should have a tentative sort of best case schedule and probably include some buffer for when things start to go wrong, right? You need extra time for if parts or materials are delayed in shipping, right? You don't get your materials on time. How long can you wait before you have to start making adjustments? And are you aware of the potential for those sorts of things, right? Have you built in a little bit of time for extra testing if you have to change the design after you start building and find out something's not working the way you wanted it to, that sort of thing. We want to know that your team understands that it's likely you will not have a perfect, flawless build or design, build, and test, and that there needs to be accommodations made for that. The other half is the budget and funding plan, which I sort of alluded to. We want to know, now this is a little harder to have a fully fleshed out budget, but we want to see estimates on what kinds of materials, what kinds of parts do you need to purchase commercially that you're not producing yourself. Are any of your parts likely to be outsourced? And I mean, instead of being a commercially available product, maybe this is something you have to have manufactured by someone else, right? So that you can then incorporate it into your rover. What's the lead time on that? How much does it cost? Travel costs. That's typically one of the largest expenses for a team out of the entire program is just getting to the competition. And any team that doesn't account for how much that's going to cost is really dropping the ball, right? We are very suspicious of a team that doesn't have travel costs accounted for, because that just tells me this team doesn't realize how much this is going to cost them to do. And like I said, funding is one of the or insufficient funds is one of the biggest sources of failure for a lot of teams. So if you don't account for travel, you're really shooting yourself in the foot. and showcase to us how it is that you're estimating these costs, these prices. If you do, if you're looking for travel costs, we want to see maybe a quote for airfare, maybe hotel, accommodations, at least, gauging prices from websites and things like that. When it comes to materials, you can literally give us the links, like, I'm not saying we'll check every one of them, but you include links to the materials that you'd be looking at buying, whether they're, commercially available parts on Amazon or something like that, or if it's just raw materials, stock, and the vendors that you'd likely be getting them from. That proves that you have a budget that's at least reasonable. And obviously build in some buffer there, just like you would with the schedule, because if you buy exactly the number, the exact amount of material you need, and then something goes wrong, you'll end up with a shortfall. So you likely want to include some amount of buffer in your materials and so on, the same way you did in your schedule, so that you have a little bit of excess for when things don't work out right. And then the other half of the budget is the funding plan, which is once you know how much everything is likely going to cost, or at least an estimate, you got to show us that you have a plan for how you're going to pay for all that. If you have guaranteed funding sources already, we want to know about those. But rarely is that enough. And so when you've exhausted the funding you already know you have, how are you going to make up the difference, right? What other means of generating funds for the program do you have planned? How much do you estimate you will make from each of those? And be reasonable here. If you estimate your program is going to cost $20,000 US and you have $10,000 guaranteed from your institution, don't tell us you're going to make up the other $10,000 with a bake sale. That's nonsense, and we know that. Like, no one is selling $10,000 worth of brownies to fund their entire rover program. You have to be reasonable and show us something that makes sense, because that's our goal here, is to evaluate what teams understand what it takes and are actually going to be able to do it. The team that says they're going to make $10,000 selling brownies looks really suspicious to us. So be reasonable and thoughtful about how you're going about this. The last part here, the endorsement column, the big thing there is showcasing any financial and administrative support that you have from your institution. Teams historically that have both the financial backing and the sort of the support network of their institutions that have a really committed school or institution tend to perform better. And we're interested in seeing that, a letter of commitment from your administration, any sort of financial guarantees, be it funding through like an engineering department or something like that. Those sorts of things carry a lot of weight in our program because like I said, that is a marker of success, or at least an indicator of likely success amongst teams. So anyway, with that, I'm going to pass the mic off to Catherine to talk about STEM engagement.
All right, so hello, and if you were a team that has been here before, STEM engagement has very much changed. So the first thing you need to know is there will be no individual STEM engagement report, okay? STEM engagement now, you have two things with STEM engagement that you're focusing. Enhancing your project's impact and enhancing your project's educational value. Those are the two things that we're looking for with that. You have two options. You can do a STEM industry engagement or a community STEM engagement. Now, for option one, which is the STEM industry engagement, you are going to look at industry professionals and community leaders. Now, with that, you are going to make sure that you're making meaningful connections that will lead to future workforce opportunities for the members of your team. Now, in the proposal phase, you will have basically your plan, and then in the ORR, you're going to have your summary of what you've done. Now, for your plan, if you do the STEM industry engagement, you're going to audit the community and create a list. You're going to look at technical expertise, mentorship, skill development, different things like that, certifications. You're going to come up with a professional development strategy that is going to include one of the following, or choose at least one of the following. You can do all of them if it works out for your team. Mentorships, skills development and certification opportunities with industry partners, connecting with team members on your career goals, and identifying potential internships, fellowships, apprenticeships, and so on. The next part of that is the community leadership outreach. All right. You're going to describe how your team has engaged with the local civic and community leaders and summarize the methods that you've used to raise awareness for NASA's challenge and your participation in that challenge. And then if you choose that one, another opportunity is to identify and outline connections that you have with those leaders. So again, if you choose STEM industry engagement, which is option one of the two options, you're going to focus on industry professionals and community leaders for that. Now, if you choose the second one, which is the community STEM engagement, you're going to connect with educators, schools, and different members of the community. Again, our focus is on your project's impact and your project's educational value. And you're building, with this one, meaningful connections to help inspire the next generation of the space explorers. Now, with this one, of course, you're going to audit and come up with a list of local schools, community educational institutions, and so forth, and start creating those opportunities through activities or events. All right? Your STEM engagement and outreach strategy is going to have a goal, and with that goal, you're going to summarize what activities and events that you're going to do to reach that goal and provide potential dates for this. That is your plan for the proposal section of this. Now, for both of these, you will do a maximum of 1 page for your STEM engagement requirement for your plan in the proposal phase, depending on which option you choose, whether it's STEM industry plan or the community STEM engagement plan. Now, again, there will not be an individual STEM engagement reports like we've had in past years, and the other requirement, you've got one in the proposal and one in the ORR. Those are the two new things that we're looking at with this. Now, getting to general submission requirements for the proposal. 10-page maximum, and we're pretty serious about that 10-page maximum. Now, that does not include your cover page or your table of contents. We're not going to go past the 10th page. You really don't need an appendice because we don't need to see FMEAs. We don't need to see all the different CAD renderings of your designs and such. Now, if you want to put an endorsement letter in the appendice, now that is okay because that is asked for in the proposal. Now, speaking of, let's see, format, it's a basic format, 12 font, Times New Roman, something similar. Page size is very similar. No columns. We do not do columns. Now, on your cover page, we've had a few teams that like to put their picture of their logo or their team members or their school as their cover page. Then the information that's asked for on the cover page, they put it on the second page. Well, you have a cover page for a reason. We want this information on your cover page. You can put a logo in the corner if you want, but make sure that this information is on the cover page. Now, institutional name with full mailing address. Don't necessarily just put the website on there. We need the mailing address. The division that you choose, whether you're middle school, high school RC, university RC, high school HP, or university HP. The date, we need a name, title, and email for your team advisor, your student team lead, and your student safety officer. Then your other team members, we need basically their names and the roles they're going to do. Now, you can put things like suspension, wheels, different things like that for the roles of the team members. Now, we've had a few questions about can additional team members be added afterwards. If we know that this is a proposal phase and that there still might be 2 or 3 team members that might be added afterwards, and that's fine. You'll let us know who those are when you get to the design review phase of the thing. Now, the last one is submission of your proposal. Again, as Zach said, it is going to be on September 15th before 8 a.m. Central Time, or you just put in Huntsville, Alabama, if you want to see the time zone to make sure you have the correct time zone. We need in this nomenclature, which is institutional name, not the initials, put your name on there, 2026, the division that you've chosen, and proposal. That needs to be emailed to us by that point as a PDF, not a Word document. Again, 8 o'clock a.m. Central Time, Monday, September 15th. That's when we need to have that. Now, one thing that's important to know is one proposal per institution, per division. Now, we know some teams, we had 10 schools last year that did an HP and an RC proposal, which is great. You need to keep in mind, that is 2 separate teams, okay? Their social media is going to be separate. All the team members are separate. We don't cross and share team members with that. So definitely 2 separate teams for that. Again, we've got the email that you're going to submit it to, institution name, year, division, and proposal. Now, it's important to know that also any late proposals will not be accepted. That's why we're really trying to 8 a.m. Central Time. If it were me, I'd send it several hours before that, just to make sure it gets here in time, okay? And just because you submit a proposal does not guarantee that you will be selected. As either Chris or Zach said, I think it was Chris, you know, we receive over 100 proposals, okay? So we obviously cannot have that, have many teams, although that'd be fun, but we can't for lots of reasons. So just keep in mind, follow the steps that have been discussed, and you all should do very well. Now, we're getting ready to go to the questions phase. Please, when you put questions in the chat, make sure they're connected to the proposal, and we will do what we can that haven't been answered already in the chat. What do we have going, gentlemen?
I haven't seen much